Assalamu alaikum. In this episode, we wanted to highlight one more thing from lesson number 1 of this unit on magnetism. Hopefully, in the computer simulation part, you are able to observe and notice a special interaction between compasses and magnets and how this actually applies to our Earth. Here's a magnet, and you'll notice that most bar magnets anyway are labeled with south and north poles to show you their magnetic polarity, if you will. Now, when we take a compass, let me turn this over here. A compass has readings showing you direction. And in this case, the arrow is the north pointing portion of the compass. So if we bring the magnet close to the compass, we'll see that this is pointing toward this end of the magnet, indicating the north. And if I flip it around, you will see that you now have the southern indicator of the compass pointing to this end. And again, I can reverse that again. But this is very interesting. If I flip the compass over, or pardon me, flip the magnet over, we'll notice that this is actually the south pole of the magnet. So if I were to situate this magnet like this, and then bring the compass in proximity, we will see that actually it's the southern indicator of the compass that's pointing toward the north pole of the magnet. And likewise, if I move the compass down, we see that it's the north needle of the compass pointing toward the south end of the magnet. Now, that's a bit confusing, perhaps. Well, think about it like this. This compass is actually like a tiny magnet in and of itself. So if I take this out and bring in another magnet, we can begin to see the interaction between two magnets, and keep in mind that the compass itself is like a little magnet in that small device. So if we take north and south poles, we notice that these attract. Opposites attract. Flip it around. Opposites attract. Now, if I were to go with the same polarity, we'll find that instead we have a repelling, where opposites repel one another. And that happens with south to south and with north to north. And so now that helps us to maybe better understand how this compass, being a little magnet in and of itself, this being its north pole, is going to be repelled by this north pole, but attracted to this south pole. Well, how does that apply to the Earth? Well, if we look back at that simulation, so as we look back at this simulation, here we have bar magnet, and we can show the compass. The red portion of this compass indicates the north pointer, and so it points toward the south pole of the magnet, and vice versa. So now we have the southern portion or southern indicator of the compass pointing toward the north pole. Well, again, this compass is actually a little magnet. So if we take the compass out and see, how does this apply to the Earth? Well, we can show the planet Earth, and you did this hopefully in lesson 1, part 4, I believe. Here's our Earth. And you'll notice that we have the northern hemisphere and the southern hemisphere. But as far as the magnetic field goes, let's pull the compass out again. And when we take the compass and we bring it, we see that it does in fact point toward the North Pole geographically. But the North Pole geographically in this representation is actually magnetic south and vice versa. So here we have southern hemisphere which is actually magnetic north, so that we have the southern portion of the compass pointing toward the magnetic north, geographic south portion of the Earth. A little confusing, but interesting nonetheless. And in fact, it is believed that the magnetic polarity of the Earth reverses every so many years. And the scientists throw out figures for the numbers of years that you have this reversal of the magnetic field of the planet. Nonetheless, it is believed to occur. And here's just an interesting interaction where we have a northern geographic pole, which is actually magnetic south, and vice versa. So this is something to think about. Very interesting. So we hope you enjoyed this first lesson on magnetism. Assalamu alaikum.